Welcome to today's webinar. I'm Terry Erzman, Chief Marketing Officer for Percona. Before we get started, I'd like to make sure everyone can hear me. So if you can hear me, if you could please raise your hand in the GoToWebinar control panel, I would appreciate it. Great, thanks everyone. We will be making a recording of today's webinar, and we'll send out a link to everyone who registered following the webinar, along with a link to the slides. So you should receive that within 24 hours afterwards. During the webinar, if you have any questions, please enter those in the questions area of the GoToWebinar control screen, and we'll answer as many of those as we can at the end of the webinar. It's now my pleasure to welcome Bill Karwin, Principal Consultant for Percona, and Bill will be speaking on SQL injection myths and fallacies. Bill?
Thanks, Terry. Good morning, everybody, or wherever you are. We're going to talk about SQL injection today, which is an important topic that has come up in the news recently as well, and has been an important topic for a long time for MySQL and databases in general. I'm a software developer by background. I've worked on a lot of projects and been using databases for about 20 years. Apologize for my voice a little bit this morning. I'm getting over a cold, but we'll do my best. For about 2 years, I've been working at Percona as a consultant and trainer, and also in 2010, I authored a book, SQL Anti-Patterns, which covers a lot of interesting subjects that I've answered questions on throughout the years. So, what is SQL injection? This may be a review for some of you, but I get this question a lot. SQL injection occurs when an application input, for example, a parameter on a URL for a web application, is combined into the string of an SQL query verbatim. That is, when in this example we see a variable that's been passed to a web app and is accessed in the manner of a PHP request, the get variable uses this user input, interpolates it into the application, and the integer is used in the expression to look up a given row in a table in this hypothetical bugs database, for example. The problem with SQL injection is that when you interpolate into a query like this as a string, the database doesn't know that it's an integer. It just knows that it's part of the string. So somebody could pass in something unexpected on the URL request that alters the behavior of your query. In this case, any expression or true is going to be true. So this where clause would match every row in the bugs table, which may be more data than you would want to have that web application present. But that's maybe not such a bad example. Somebody might have access to all bugs anyway, so it's not really giving them something illicit. Another example might be if a application is changing the password for a given user account in this application. The values passed in on the URL would be interpolated into the string to change the password and affect the given account ID. So then somebody who is mischievous or malicious could pass in extra content into those variables and change the behavior of that statement. There's two different ways that this can happen in this example. One is that the password string could actually terminate the string literal, terminate the quote, and change another column, affecting the behavior of the query to change another column. And it could also affect multiple rows and just not the one that was intended. So in this case, two different bad effects could occur. You could change the password and change another column in that table to give the user administrator privileges, or change the password and administrator privileges for every account in the database. Then they could log in as anybody, do anything they want, and it wouldn't be traced back to them. So now that we know what we're talking about, what this presentation is going to cover are some of the myths and fallacies. That is, I see a lot of people give advice in blogs and books and articles about what is the effective defenses against SQL injection to try to mitigate this problem. And a lot of them are incomplete, and that's why I wrote this presentation. The first one is, well, SQL injection has been around for a long time. We've known about this since it was first identified as a security problem all the way back in 1998. And so it must have been solved by now, so I don't have to worry about it. But to the contrary, it's still going on. One of the largest, actually the largest identity theft that occurred in history on the internet was perpetrated by this guy. He uploaded his code using an SQL injection exploit to credit card processing servers and debit card processing servers. And he stole 130 million credit card numbers and debit card numbers with their confirmation codes and shipped them off to his colleagues overseas. He was caught. He was sentenced to 20 years in jail in federal prison, but the cost was the damage was already done, and the cost to the victim companies was huge. For example, Heartland Payment Systems had to pay $12.6 million just in fees to the victims who had their credit card numbers stolen, and also just in fees as penalties. On top of that, they're now going to have to launch an engineering project to try to find out what vulnerabilities they have in their system and to correct them. Even more recently, there was a publicized vulnerability in Ruby on Rails that may affect many applications that are written with that framework. So if you're using Ruby on Rails, make sure you've updated to the most recent release, and there's a link there to more information on that problem. I will be providing the slides, and I'll give a link at the end so that you don't have to write down these URLs as I'm talking. In June of this year, LinkedIn.com was in the news because some Russian hackers had acquired over 6 million user credentials from LinkedIn.com. We still don't know all the details about this, but we've already seen a class action lawsuit that mentions SQL injection as the means by which the attack was accomplished. That's unconfirmed, but we'll see more details in the future. And just this month, Yahoo Voices, one of the subsidiaries of Yahoo, was shown to have leaked email addresses, and the perpetrators themselves announced that they accomplished this with a union-based SQL injection. I've included links to the news about that, and also an article not specifically about this case, but it explains union-based SQL injection. About defenses regarding SQL injection, one of the most common pieces of advice is to escape input. For example, in our update statement that changes the password for a given account, if you just insert backslashes before those single quotes, you can defeat the extra semantics that are introduced by that SQL injection, so that the password gets changed to a long string which looks funny. It has commas and parentheses in it, but it's actually still a valid password and is not going to change the administrator column. Likewise, if we filter the account ID in this input to just be an integer and strip off the remaining characters, we defeat that Boolean expression injection. Accomplishing this in a language like PHP is pretty simple. There are functions provided for it to escape strings and to coerce other inputs to integer types. And if you use more modern PHP extensions, there are still functions. In fact, in almost every language and every framework, database access libraries provide functions to do this, to do the appropriate type of quoting for dynamic values that you can then safely interpolate into your SQL strings. So this is true for C# and Java and Ruby and Python. There are functions that exist for this. So this is a good technique. The problem is that it doesn't cover every type of input that you would want to make dynamic in your SQL queries. For example, in this query where we want the user input to determine the column by which we sort and the direction in which we sort, ascending or descending, we don't have functions in most libraries that are provided by database access layers to quote appropriately the column names, so identifiers, table names and column names are given quotation rules that are different from string literals. And SQL keywords like ascending or descending don't have any quotes around them at all, so how can you escape the embedded quotes? The next thing I see people try is to escape over and over again. If the one level of escaping is good, then more must be better. And this is an example that I actually got from a posting on the forum where people were the author was asking, how can I most safely interpolate strings into my SQL queries? So he had a function that he had written, sanitize, in PHP, and he had found every function that looked like it's filtered or escaped characters within a string, and he used them all. He actually thought that every single one of them would add to the strength of his secure function, and therefore he could sanitize. And the only thing I thought about this when I saw this was the scene from the Star Trek movie a few years ago where the villain sees the Enterprise and he tells his staff to fire every weapon at the Enterprise. There is just the one function that is provided, MySQL real escape string, in the MySQL extension of PHP, and that's really adequate for this purpose. There's no extra functions that you need to use to achieve the same goal. So if you are using the escaping method of securing your inputs, just the one. It seems so straightforward to write these strings out in a form that has the quotes and special characters escaped. It seems like you could just do that with a regular expression. Or in the case of PHP, there's actually a function called add slashes that finds those special characters and adds slashes for them. But there's actually some subtleties to this too. There was a case where, or at least a scenario, in which a request that has a particular sequence of bytes, there's the hexadecimal characters BF and 27, that gets passed into add slashes. Add slashes sees the hex code 27 and sees that as a single quote and inserts a backslash. Unfortunately, the preceding character combined with the backslash forms a valid multi-byte character in the Chinese character set. So this allows an attacker to insert SQL injection, even defeating your add slashes function or any other regular expression-based function which is not aware of character sets. So do use the functions that are provided by the database access layer. Don't rely on regular expressions. Regular expressions are not character set aware. If it's already in the database, then the data is safe. I can then use it in subsequent SQL expressions because we've already vetted the data, otherwise we wouldn't have allowed it into the database. However, you can not necessarily rely on that. You have to make sure that strings are going to be vetted when they come from any kind of external source besides your code itself, including a file, including the database, including a web service, any source that is not trusted, that is external to your code and you haven't actually validated that. In this example on this slide, we can see that the product name could be fetched out of the products table and then used in a evaluation in a search on the bugs table. But what if the product name itself contains special characters? Those would be fine to put into the database if you had escaped them properly when you inserted them, but they still have special characters like single quotes and parentheses and so on. It wouldn't be illegal to have that be a string, but it would cause problems if you try to interpolate it into a subsequent SQL query, and this is not an uncommon programming paradigm. So whatever another that we see cited a lot, using stored procedures helps to prevent SQL injection as the assertion. And in fact, it can give you some kind of protection. For example, the data type that you declare for the input of a stored procedure can serve to coerce a value to a certain data type that is going to strip off any payload that is malicious. So in this case, it only accepts an integer. But SQL stored procedures do permit dynamic SQL, just like an application does. So if you pass in strings, which get interpolated into your dynamic SQL, it can change the semantics of the query. In this example, it would be the same as our order by dynamic column name and in a dynamic direction, but it still permits illegal string values to be passed to the as parameters to the procedure. There's nothing about the procedure itself that guarantees against SQL injection in this case. This story even came up on the daily WTF. The story here was that the database administrator insisted on making all queries from the developers go through a stored procedure layer. So he said, you have a new query, you contact me, I'll write a procedure for you, and you can then do that. So he was bothered by how frequently he got requests for SQL queries from the developers that were simply select star from this table, select star from that table. And his response was to write one procedure that would take the table name as an input and do a dynamic SQL query against that table and just hand that back. Suddenly his phone stopped ringing. And the reason was that the developers realized that they could pass in a subquery as a derived table, and therefore they could do any kind of query that they needed to, even the complex ones, and they don't have to wait for the DBA to create a stored procedure for them. The DBA was happy because his phone stopped ringing. The developers were happy because they could get everything they wanted done. But now we've lost that check where the DBA was reviewing all the SQL that was running against his database, and the developers may mistakenly introduce SQL injection vulnerabilities as they write those subqueries that they pass to that procedure. What about trying to limit conservative SQL privileges so that if a given user doesn't need to insert to a table, we don't give them privilege to do so? Well, here's an example of a query that you can get turned into a denial of service attack. Say you had 100 rows into this bugs table. So doing a Cartesian product self-join against that bugs table 6 times gives you a trillion rows. And to be even more mischievous, just tack an order by one on the end of that, and it will try to do a file sort on disk of a trillion rows. It still has very minimal conservative SQL privileges, and you can still turn that into a denial of service attack if you can convince somebody's web application to run this query. I've even seen, this is a real example that I saw posted by a programmer of their application. I've changed the name of the domain, of course, but they actually would take verbatim SQL as a get parameter on the request and just execute it verbatim without doing any checking against it. So they're probably in a high-risk group. Well, we talked about the risk of having attackers make illicit requests from the internet, but what if your application is just an intranet application? We're all one big happy family here. Nobody in our company is going to cause problems, so it doesn't need to be coded in a secure way. But what if this is your manager? And he comes to you one day and he says, yeah, I really like the way that you coded that intranet application. In fact, our partner liked it too, so we're going to have to ask you to open up the firewall and let our business partner access the same application. Yeah, just get right on that, please. So then that you have an application that has not been coded for proper secure methods accessible now to the outside world, and whether that partner has enough security to prevent illicit use of that hole through the firewall is not up to you. You could also have a case where one of your colleagues in your own company copies some of your code from your intranet application and uses it in an external application. And now the same function of code is being used in an area which is much more susceptible to attack. Trying to argue the fact and say, well, no, we can't open up the firewall or copy code to the outside application until we do a full security review and improvement to that code can be an uphill battle to try to convince people that we need to delay that project, and that can be hard to justify. Frameworks are very popular these days. For the past few years, a lot of application languages have been using application frameworks to abstract the database access and do a lot of the work for them, which is good for developer productivity, but it has some other costs associated with it. Every such framework that I've come across allows you to override the framework and to provide SQL directly, or at least in fragments. So here's an example from Rails active record that allows you to specify fragments of SQL syntax in the join condition or in specific clauses like the order by clause. And here again you have a opportunity for the developer to naively or through just an honest mistake introduce untrusted input interpolated into those strings that are used as fragments of SQL. And those strings are simply appended into the SQL query by the framework, and it gets executed against the server. So here's an opportunity for unsafe input to creep in. And I've never come across a framework in any language that doesn't permit this type of override where the strings get introduced directly into the SQL queries. These frameworks provide abstraction layers, but those abstraction layers don't cover every single case that you could have for writing SQL. So ultimately, the developer still has to be aware of the safety of the strings that they're creating and the inputs that they're interpolating into those strings. I tell people that a framework or a database layer only prevents SQL injection like a toothbrush prevents cavities. You have to use it consistently and properly and mindfully all the time. Query parameters. Some of you have probably been saying, oh, I've heard about query parameters. That's really the answer. And I've read that query parameters do the quoting for you. Sort of. Here's what we've seen before with interpolating dynamic values. You have the opportunity for a variable to come into your SQL query from user input or from application input. In the case of a parameter, when we write the SQL string, we leave a symbol as a placeholder. By standard, it's a question mark. Some databases also support a named parameter syntax, so the colon preceding identifier. Then after the query string gets passed to the database server, it's parsed into an abstract syntax tree like this. So it breaks it down and it knows what elements that it needs to evaluate. The parameter placeholder is part of this abstract syntax tree that gets parsed, and the database knows, here is a placeholder. I should expect to see a real value provided before I get around to executing this query, and I know where it goes. It goes right in the place of this in the tree. So when the value comes in, it substitutes it for that placeholder and then executes the query. When we had the interpolation case that allowed for user input to change the semantics, we can see that it also changed the abstract syntax tree because the malicious payload was provided before parse time. That is, it was interpolated into the string, then the string was sent to the server to be parsed, and it now changes the shape of the tree. That's how an SQL injection really occurs, is changing the syntax and the semantics of the query by changing the string that gets passed before parse time. In the case of parameters, the parse time happens before the potentially malicious payload arrives. So now there's no way for the malicious content to change the shape of the syntax tree, and it knows that even though it looks funny, this string really belongs in this one single bubble in the tree. Another way to visualize this is as a sequence diagram where the prepare step sends SQL to the server where it's parsed into its syntax tree form. Maybe some optimization is done at this time. Then executing query sends those parameters to substitute binding in place of those placeholders where it then executes and returns the results. This allows you also to repeat the execution of the query by sending different parameters which get bound into the same place. Therefore, the server has to keep track of the locations that are placeholders even after it has bound parameters the first time, because you might want to execute the query multiple times with different sets of parameter values. Great, right? SQL query parameters prevent SQL injection. Well, they are very useful. I do recommend using query parameters, but they don't tell the whole story. One parameter placeholder can take the place of one scalar value or one constant value, where you could otherwise put a string literal or a numeric literal into your query. You can substitute that with one parameter. But you cannot use a parameter for a list of values, for example, a comma-separated list in an in predicate. You can't use a parameter for a table name. If the database has to do parsing and validation of your query at prepare time, it needs to know the name of the tables and columns that you're referencing so it can tell you if those tables and columns exist. And perhaps it will decide at that time to use certain indexes as well. Likewise, the columns cannot be made into parameters. This is a very frequent type of question that I see. People try to use parameters for table and column names, and they can't do that. And likewise, any other SQL keyword or syntax, full expressions, things like that, those can't be. And here's the summary, all the different types of items that you could dynamically add to an SQL query and how they could be accomplished with interpolation versus parameters. And you can see that interpolation does permit you to add in table names and column names and SQL keywords dynamically, because those happen before the string is sent to be parsed and prepared. In the case of parameters, the example with the multiple parameters can be done with a comma-separated list with as many parameters as you have elements in your list. But you can't do it at all for table names, column names, or keywords. So what do we do for those cases? My solution is what I call whitelist maps. This can be done in many programming languages, but I'll show you the example that I use in PHP, just because PHP is so widely used. In this case, in our example where we want to order by a user-specified column and in a user-specified direction, our SQL injection susceptible example is that we copied those values from the input of the application and interpolate them directly into the query, and that's not safe. For each one of those distinct inputs, the sort order and the sort direction, we could declare a mapping array that maps the values that are being given by for the application request, that is, those values that are given in the URL request, and the corresponding value that we want to interpolate into the SQL string itself. So now when we see a value status for the sort order, we use status. When we see the value date, we use date reported, because date reported is the physical name of the column. Whereas in the application interface, we might want to simplify that and use a different word that makes more sense to the application. Likewise, up and down correspond to ascending and descending, so the SQL keywords. Checking this is very simple. You can just check to see if the sort order corresponding to the user input exists, then use it. If otherwise, use a default. This means that any kind of malicious input will naturally not correspond to a key in that hash map, and therefore it would just resort to the default. And you can even get more concise with PHP 5.3 syntax to make this a very simple and easy to read expression in your application code. Therefore, we have whitelisted values. We have values that can be interpolated safely into our order by clause because we know that we have them hard-coded in our application. We've already decided on them, and any illicit values that the user tries to provide will simply not look up one of those values that we've already predefined. So this is a good case where we have now a solution to prevent or defend against SQL injection attacks, even in cases where the escaping and parameterization doesn't help. You still can use escaping and parameterization because they are very helpful in many cases, in fact the majority of cases, but now we have this extra method that helps in other cases. It has a few other side benefits. You have a web interface which is decoupled from your database schema. You can change the name of your column without having to change your usage of your web application, and vice versa. The coding of it is very simple. It can work in conjunction with any framework that you happen to use, so you don't have to learn a whole new library or install any software. I like solutions that are simple like that because they're easy to understand, they're easy to deploy, and they tend to work. Another fallacy I've read repeated over and over again is that SQL parameterized queries, that is prepared statements, hurt SQL performance. It stands to reason, right? Because you need to do a prepare and then you need to do an execute, providing values. That's twice the round trips. You're making two different requests to the database server. But I said, really? Let's put that to some measurements. And I started doing some profiling of a PHP application showing both prepared and non-prepared execution of the same query, and in different interfaces because PHP has different extensions for accessing a MySQL database. It has the plain MySQL extension, which does not support prepared queries at all. It has MySQL improved, which has a non-prepared and a prepared mode, and PDO, which has a non-prepared and a prepared mode. So I measured what the MySQL reported as the profiler execution time of the query, and that's the blue column. It doesn't change much, and it's fairly low, despite the fact that we vary between non-prepared, prepared, non-prepared, prepared. If anything, it looks like it's slightly faster to do the prepared statement, and that includes both the prepare and the execute step in my benchmark. Whereas elapsed, the red column, was measured in the application layer itself. So it looks like just the overhead of running the PHP code to send the query and get the results back, as well as whatever overhead of the network was involved, was actually a lot more significant than the time it takes to do the query on the server. So it may have, the truth to this myth is that it may have some extra overhead because of the application language, but not because of the database itself. This test was run for a very, very quick, simple query. So you can see the number of seconds in the scale of this graph is in the milliseconds. What if we ran a more complex query that takes over almost a second and a half? Then you see the profiled and the elapsed is almost identical. Whatever difference added by the overhead of PHP is diminishes down to an insignificant portion of the time. And again, the execution time on the database server is so similar that it's not really worth worrying about. There's no difference, and there's certainly not any difference like doubling it for the double round trips. So people who blog about how much overhead prepared queries cause are obviously not basing that on actual measurements. What about another one, a proxy or firewall solution? If we can put in some kind of middle tier to recognize the content that flows between our application and the database server, find out which queries are SQL injection queries and block them. And a couple of products exist so far for this. There's one from Oracle called the Oracle Database Firewall. It supports a variety of database servers, not just MySQL and not just Oracle. The way it works is you teach it while you're doing some test runs of your application, and it goes into a learning mode. So all the SQL queries that are being learned during your test run are added to a whitelist, and then subsequently when you go into production, it will block any unknown SQL queries that aren't in your whitelist. This has some sense to it. It seems like it's okay on the surface. And there's a third-party product also that's gaining popularity called GreenSQL. It also functions as a reverse proxy. It sits between your application and the database server. And it works similarly. It can learn your whitelist, or it can operate in a sort of automatic mode, so it tries to detect things that it considers suspicious. Accessing sensitive tables, comments inside SQL commands. Sometimes SQL statements work by commenting out rather than adding content or adding comments. Setting things to an empty password This one always gets me, an OR token inside a query. Any query that involves an OR Boolean operator, that must be very suspicious. It doesn't seem very plausible to me. Any SQL expression that always returns true, that could also be a case where you have legitimate uses of that. So it doesn't really wash that these constitute suspicious queries for me. Even the makers of these products admit that they are not perfect. In fact, a great quote from the Green SQL site is that it sometimes generates false positives and false negatives. So it should not be treated as a thorough security solution. What I worry is that by using these types of products, a company may discourage or skip doing proper code review and proper secure coding practices because they think that they are being protected by using this proxy solution. So they don't do their due diligence on writing secure code. It could also be a problem if you need to do frequent or urgent code pushes to your production environment, if you have to then teach your SQL firewall about the whitelisting of new SQL queries. It could slow down your deployment process or complicate it. There are some dynamic SQL queries that would be so variable that you wouldn't be able to whitelist them. They change the forms of the expression so significantly that it wouldn't be able to be a pattern that could be added to a whitelist. And this still wouldn't solve SQL injection problems in stored procedures. All the proxy would see is a call to a stored procedure with some literal string which internal to the stored procedure is interpolated into a dynamic SQL query and then causes a security problem. So these proxy solutions should be taken with a big grain of salt and not relied upon too heavily. What if we switch away from MySQL completely and SQL databases and go to a NoSQL solution? By definition, a NoSQL database that does not support SQL can't be affected by an SQL injection attack, right? Well, there are a larger class of security threats called code injection. And this could affect if you have an application that runs eval to evaluate a string as code, or runs a system function call to run a command line on the operating system. So any kind of case where you take user input and unsafely execute it as code is called code injection. And this certainly affects cases where you would dynamically create a function to run against a NoSQL database. For example, MongoDB and others support MapReduce functions, perhaps written in JavaScript or some other scripting language, and you can construct the code for these MapReduce functions as a string and then execute the function against your cluster of NoSQL database servers. By creating this function as a string, you've created the opportunity to run unsafe user input through it and execute it verbatim. This isn't just an academic exercise. There was actually a project called Diaspora, which was reviewed by a security expert, and he found cases where user input was unsafely interpolated into a JavaScript MapReduce function. So here's the topics that I've covered, and you can notice that many of them, the myths are of the nature of somebody has identified a single thing you can do as the fix, quote unquote, and the reality is no one of these is the sole fix. There are many different techniques, and by nature in a security problem we need to be aware of all the tools at our disposal because we probably are going to have to use multiple defense tools in any given application project and use them appropriately. So get a big toolbox and fill it with tools. If you want to read more about this topic in SQL injection or other things that I've covered, check out my book, SQL Anti-Patterns. And also I wanted to remind everybody that Percona does cover a wide variety of really interesting technical subjects at their Percona Live conferences around the year. Here are some upcoming dates in New York, London, and Santa Clara, and please join us at some of these events in the future. My slides I post at slideshare.net/Bill Karwin, and they're Creative Commons licensed. So thanks very much for listening to my talk about Sql injection. It's a very important subject that I hope everybody listening will become an advocate for. If you are responsible for developing code, please follow secure practices. If you are an operations specialist who works with people who develop code, please become an advocate and let them know about the range of techniques that they want to have in their tool belt to defend against this. So thanks again very much. Do we have any questions?
Okay. Thanks, Bill. Again, everyone, if you would like to ask some questions, please submit them through the questions panel on the GoToWebinar control screen. First question we have, Bill, is does the use of parameters, particularly Odbc parameter class in .NET, qualify as an appropriate security mechanism for normal where interpolation?
So parameters in data access layers like Odbc, are those sufficient? Usually, yes. There's two different ways that those parameters can be used by that incoming layer, and the first way is that it functions as a real query parameter to the database server, and it separates the value from the prepare stage, and that's a very secure way of doing it. Some of the frameworks actually introduce a slightly different mode where they actually do the interpolation for you before they send the query string to the server, and there are some of the frameworks provide that as an optional mode. PDO in PHP, for example, does that. That should still be pretty safe because the people who have developed that have tested it thoroughly, and they are often experts in the proper way to interpolate so that it's done safely. So for cases where you are adding in dynamic values to a query as opposed to table names and column names, yes, I think that the parameters are the way to go.
Okay, very good. Next question. Could you specify input data strings I should use to find a security bug in my code? Interesting
question. The input string that you should put into your inputs to try to test for this would be, for example, something that terminates a string, so it contains a single quote in it, and then has some additional content beyond that to show that your input is being interpolated in and then is being executed. It doesn't really matter what content you have following the string if you're using this for testing. In fact, nonsense text could be just as useful for performing the test because it would at least alert you to the fact that if you get an error, then it's some string that has been input unsafely, if that makes sense. If you have input that terminates a string that's dynamically interpolated into your query and then has gobbledygook following it, it would be invalid SQL and it would raise an error, hopefully, and that would alert you to the fact that this is an unsafe interpolation of user input. You don't necessarily have to perform a clever exploit on your own application in order to demonstrate the case where it's unsafe.
Okay, excuse me, next question. What would you say are the top 3 tools to prevent SQL injection?
The top 3 tools, well, I would refer to them as techniques rather than tools. I think the ones that I would look for first, well, actually the very first one would be code review. That is, go through your code. Every case where you have an SQL query that is interpolating dynamic variables into it, find out where those variables came from and if they had come from a trusted source or had been filtered and escaped properly. So code review is the primary tool that we have for us. The second one is query parameters. The interpolating dynamic values, that is scalar values, into your query. The best technique is to use query parameters, as I described earlier. And the third one would be the whitelists. If you have items of dynamic content that cannot be added into as parameters, you can whitelist them. And I showed that method.
Okay. Question about your book. Is your book available through any of the digital library subscription services?
The book is available at the URL that you see here in print or in ebook format, and it's available for Kindle and iPhone and PDF as well. The other ebook subscription sources like Amazon.com, it's not available there, just at this URL that I'm showing you now.
Okay. Next question. Should I delete all unsafe sentences from user database before I store the data in the database?
Delete all, well, if you are using the values properly once they're in the database, then there should be no danger of having any kind of content. You could store full SQL strings in your database as long as you use them responsibly if you ever get them out of the database again. And your question also makes me think of another security threat, which is not specific to database, which is cross-site scripting. There's a whole other area of trying to be safe about outputting content to the HTML presentation to avoid illicit embedded JavaScript to run. And that's a topic for another presentation. Or you can go to OWASP, OWASP.org, and find out lots of tips about both SQL injection and cross-site scripting protections.
Okay. Next question. What is the best way to protect an in list?
The good question. The in list is problematic because an in list would be a variable length list of scalar values. If you have an array of unknown length that you're trying to put into a predicate safely, the temptation would be to interpolate that in there because you can't use a single query parameter. So what I like to do is actually write code to count how many elements in my list and then add that many query parameter placeholders. So it's very easy to get the number of elements in an array, and it's very easy to repeat the same number of elements of a comma-separated list of question marks and interpolate that into your SQL query, and then you can pass your array as your array of parameter values. I have an example of that in my book of a two-line solution in PHP to use the built-in functions like length and array fill and array keys and some of those very high-performance built-in functions in PHP to make that a dynamic solution. The alternative solution, if you don't want to do parameters, is if you've got an array of inputs and you want to add that into an in list, you could interpolate it in there if you coerce each element in the array to a safe data type. So for example, making sure that each one of them is a bare integer and not anything else can be a safe method of doing that. So once you've made the input safe, you can interpolate it into that in predicate safely. But it takes some care and thinking about it pretty carefully to make sure that you've accounted for that. The difficult part about these security things is trying to put yourself into the mindset of an attacker, saying, if I were an attacker, what kind of input could I provide to this application that would cause trouble? And then, as a programmer, defending against that, come up with a way of filtering the input or escaping the input or otherwise using parameters to try to defeat that.
Okay. Next question is, my preferred variable parameter format, bug ID n, boy, this is maybe too much to try and read. How about, what about inserting binary data? Do I have to protect myself in this situation?
Sure. If you're inserting binary data, often when binary data is formed in a literal form, it could be a quoted list of binary bytes or a quoted hex string. And when it gets into the SQL query, and those can be interpolated in an unsafe just as easily. For those, I would recommend using parameters, just like the non-binary input values, and that would be an effective defense.
Okay, next question. Would a SQL proxy be a good tool to use as a notification service instead of using it as a tool that blocks bad queries?
Several of those SQL proxies do function as either an alerting service or as a blocking service, so that it doesn't necessarily stop the suspicious query, but it just lets you know that something happened. And I think the same warnings that I had apply, that how does it determine what's suspicious? And it may not have blocked access, but it may be giving you false positives, that it finds cases that it's warning you about which don't demand your attention. And then once you start getting false positives, you naturally start tuning out the warnings. You start saying, oh, yes, my pager just went off. It told me about yet another query that had an or in it. I don't need to look at that. And because you've tuned it out, you'll start missing the legitimate warnings that you actually should pay attention to.
Okay, next question. Is it the DBA's job to review the code that might be susceptible to SQL injection?
Excellent question. This question isn't necessarily a technical one, but a organizational one. Whose role is it to be the gatekeeper there? I think a DBA, because they're much more trained in the SQL potential in most organizations, could be a very helpful person in that. They may be a good person to be part of the review team. But I like to say that ultimately it's the application developer's responsibility to code in a secure way, and they should be doing both self-review and peer review and even group review of the code that is on their site architecturally, and code, line by line code, not only for SQL but other security issues as well. So I think it's primarily the developer responsibility, but I think definitely the DBA could be a valuable contributor to that, because they would be able to advise on what's the potential damage, what's the potential solutions in SQL syntax if they're more skilled in SQL syntax, and also the modes of accessing the database, what functions are available for quoting and parameters and so on.
Okay, very good. We just have the one question left that I think probably is better answered in writing. So with
Do you
that,
want to follow up, and I can post answers to some of these questions on the blog as we've done in the past.
Yes, exactly. I'll send all these after the webinar to you.
Great.
So Bill will blog on mysqlperformanceblog.com with some answers to some of these questions, or with some further expansion on some of the answers. And we will send everyone via email a link to today's webinar recording within the next 24 hours. I'd like to thank Bill and all of you for attending today's webinar, and please check back on the percona.com/webinars page often, as we are constantly adding new webinars, and I look forward to seeing you at a future event. Thanks, Bill. Everyone have a good day.
Thanks, Terry. Thanks, everyone.